Okay, so this is 7.9. This is some math and trigonometry in the real world. This is the last normal section of trigonometry. There's a couple honors ones left, but this is the last, real life application use of trigonometry here. So, first couple things, terms we want to get out of the way first. I'll zoom in for them real quick. And I guess I'll just zoom in for this altogether. All right, so the angle of elevation and the angle of depression, right? Their angles created above the horizon when looking at that object. So that would be this angle right here. So if I'm at angle M and I'm looking up at the airplane, the angle at which I'm looking up at the angle or at the airplane that's the angle of elevation. And if I'm riding on the nose of this airplane right here, or maybe I'm in the cockpit, and I'm looking down at the person looking up at me, that's the angle of depression, right? And the angle of like this line DW and this line MR, for all intents and purposes, these are parallel lines. So I ask you, why are the angle of depression and the angle of elevation? I'm telling you that they are congruent, right? Why are the angle of depression and the angle of elevation, why are they congruent? I'll let you think on that for a second. Well, if you look at this line right here, and even if you were to extend this line a little bit on both ends there, what would that look like to you if these lines are parallel? Well, that would look like a lot like a transversal, right? And angle DWM is congruent to angle RWM because they're alternate interior angles, right? Actually, I should go down here. They're alternate interior angles. They're alternate interior angles, right, of this transversal, right? So the measure, so angle DWM, this one, and RMW, this one, they're congruent. Okay, now let me ask you, let's say for instance I have this airplane. It's flying at an altitude, this altitude here, this altitude, the y value of this right triangle, the y value is flying at, say, 2,500 feet. It's coming in for landing. 100 feet. All right, snapshot. Okay, using algebraic expressions, how far does it physically have to travel? Not like linear land distance, but how far physically does it have to travel in order to make contact with land? How would you figure that out? Well, if we're talking about that measure of this angle, and then let's say we would need to, what kind of how would you set this up? Well, let's say we would also need to know the measure of angle M. We'll say the measure of angle M equals, we'll say it's 37 degrees. 37 degrees. Okay, so now we would have to set this up. What function would we need to use? Well, we have measure of angle M. We need to figure out this line. This line is opposite of the 90-degree angle, so that is the hypotenuse, right? This is the hypotenuse, and this is opposite of the 37-degree angle, or theta, if you will. All right, so this would be the sine option, right? So we know we need to do sine theta equals opposite over hypotenuse. So we're going to solve for hypotenuse. So hypotenuse equals opposite divided by the sine theta. Sine theta. So now we're going to plug and play, right? Now this is going to be MW, technically. MW equals 2500 divided by the sine of 37. Okay, so we're going to go 2500 divided by, now should that be longer or shorter than 2500? That should be longer. Okay, so divided by 37 sine equals, yep, so that should be equal to 4154. Okay, so that's feet. Okay, so there you go. That's how you'd figure that out. Okay, so now let's look at something like the swimming pool one. I like the swimming pool one. I'm not gonna go too much into this one. These over here, and I think you guys can figure this stuff out. It's pretty simple, but I'll give you one more example. Okay, so we have this swimming pool here. It's 48 foot long and 4 foot deep at the shallow end. Okay, so this is 0 feet. This R and E and X, all of these are 48 foot long. Okay, there's our 90-degree angle right there. You can hardly see it. Okay, this is 4 foot deep. Okay, that might be irrelevant. That might be our 0 point. Okay, there is a steady decline of 14 toward the deep end of the pool. Okay, so that would mean that this angle here is 14 degrees, right? Because this is steadily declining at 14 degrees. Or, yeah, and that also means that this is 14 degrees, right? Because this is parallel to this, and that would be a transversal. So that's 14 degrees, and that's 14 degrees. Okay. And then rectangle RLSY are shown to model the transition from the, okay, label them appropriately. Okay, R, L, R, R, L, S, Y, and they're already labeled, looks like, S, Y, E. Okay, that looks like all right. ES, so it wants us to figure out the length of this. All right, so it wants us to figure, so we know this length, and it'll give us the deep end. Does it give us the deep end? Okay, LS. 4 foot deep. How deep is the deep end of the pool? Okay, so it wants us to figure out. Oh, first, there's two questions. How deep is the deep end of the pool? And how long is ES? All right, so whatever we figure out this length is, EY, we have to add 4 feet. Okay. So, first thing we got to do is figure out, this is the So that we got this angle to work with, and we got this length to work with, right? So this is the opposite of theta, and this is the adjacent of theta, right? So if we want to figure out the opposite, what would we use, right? We would have to use the tangent. The tangent of theta equals EY over YS. Okay? Opposite over adjacent. We got to solve for EY. So YS times the tangent of theta equals EY. All right, so we got that. Okay, so now we do, do we expect that to be bigger or smaller? It looks like it's going to be, by the drawing, it looks like it's going to be smaller, but don't be deceived, it could be bigger. All right, so the tangent of 14 degrees, so it's going to be 48 times the tangent of 14 equals EY. Okay, so 14 tangent times 48 equals, we're going to say 12, equals 12. 12 feet equals EY. Now the depth, RY, equals RE plus RY equals 4 plus 12. So RY equals 16. That is the depth of the pool. So that is the depth of the pool. Okay, so now it wants to figure out what is ES. So we know that this length here, EY, is 12. Okay, so right now we're trying to figure out what the hypotenuse is. So you can't tell that. It's supposed to be orange, but that's the hypotenuse. Right, so again, that's 14 and 14. That's our two parallel lines, right? And the hypotenuse of that line is also our transversal, right? So that's 14 and 14, alternate interior angles. Okay, so what would we have here to figure that out? Well, we could use well, that's 14. That's I mean that there equals 90, so we could do cosine, but let's just keep it easy and do this opposite over hypotenuse, right? So opposite over hypotenuse is sine, right? So the sine of 14 equals opposite 12 over ES, right? Because that's the hypotenuse. All right. So ES is going to be equal to, therefore, ES equals 12 divided by the sine of 14. Now, is this going to be longer or shorter than 12? Well, it should be longer than 12. And we know the sine of anything is less than 1. So, that means it's 12 divided by anything less than 1 is going to be greater than 12. So that makes sense. Right, so 12 divided by 14 sine equals, so that equals 40, that equals 50 feet. That equals 50 feet. Close enough. Equals 50 feet. Okay. That was only 14 minutes. We can do, that's good enough. That's good enough. If you guys have any questions about these ones, we'll cover these ones in class too. But it's all the same stuff, right? Just recognizing what function you need to use, put it into the equation, right? And then algebraically solve the equation, right? And knowing how to type it into your calculator. Okay? So I hope that makes a lot of sense for you guys. If you have any questions, please let me know. And we'll get back to this in class. Have a great night.